tallest building in the world compared to me. So here next to me now is a transistor from 1968, 20 years later. Moore's law says that that's enough time for the number of transistors per chip to double 10 times, which means they've cut the size of a transistor in half 10 times. Now, computers in 1968 were still primarily used by governments and research labs, and were still the size of rooms and cost hundreds of thousands to millions of dollars. This is still pre-internet, but they've already come this far since the earliest days of semiconductors. It's wild. All right, another 100x shrink. So now it's getting ridiculous. I am now 2 micrometers tall. At this point, I'm actually literally invisible to the human eye, which kind of feels like a superpower. But I'll also need to be very careful because a human hair is like a cliff the size of a 25-story building. A single grain of rice at this scale would be the size of Mount Rainier. I could live comfortably inside a single groove of a vinyl record, and a 1 millimeter droplet of water would feel like a massive lake. This is the scale that bacteria live at. It's funny because physics also starts to behave kind of strangely at this scale. Air molecules, for example, are too large for these tiny lungs to breathe, and even the wavelength of visible light is as tall as I am, so my tiny eyes wouldn't exactly pick it all up. And the world would look kind of blurry and wavy. But somehow, by the 1980s, humans have found a way to consistently manufacture functional electronics at this size. Just like clockwork, Moore's law continues to see dramatic and consistent improvements of the semiconductors in our computers. So by 2003, the computers that we had, they started to resemble the ones we have today. Laptops are starting to go mainstream. Wi-Fi is a standard. Windows XP is the most widely used desktop operating system. Good times. But if you can believe it, we have to shrink down 100x yet again. Okay, 20